Good morning, everybody. Just a quick review before your quiz today. I wanted to make sure that you were thinking about these types of problems correctly. And so I have a bit of a to-do list, if you will, for when you should be doing different things with exponents. So the first item that is really good to think about overall is, when do we subtract exponents? We've seen that a lot with these questions. And if you think about it, subtracting exponents usually comes in fraction format, where you might have y to the 10th over y to the 3rd or something along those lines. You'd take 10 minus 3, big minus small, and you'd be left over with y to the 7th, something like this. Now, what if we don't have nice whole numbers? Because on your quiz you probably won't. This whole section is about fractional exponents. So what if it is 10 thirds over 3 fifths? Well, then you have to get common denominators because you're subtracting fractions. And so 3 and 5 would meet up at 15, which means you adjust them both and you see which one is actually bigger. So that would look a little bit like this. Multiplying by 5 on the top and the bottom, multiplying by 3 on the top and the bottom of those exponents respectively, you end up getting 50 fifteenths, and you get 9 fifteenths. So you can still see the top is bigger overall. And so when you subtract them, 50 minus 9, you'll put your answer up here in the top part of that fraction. So subtracting exponents is something you need to be familiar with and comfortable with. So I guess when would we add exponents? Well, that is not a relationship that is top to bottom, like the y's here. That's a relationship that is side to side. So if we have x, maybe x squared times x to the 4th. Well, if you have those two amounts of x's really piled up together here, you have 6 x's, x to the 6th, and so you add the exponents together. When they're whole numbers, it's pretty easy. When they're fractions, it is pretty easy. So what if I had 3 halves and 3 fourths? Well, again, in order to add those fractions together, I need to adjust this first fraction to get it to be an amount of fourths. So this would be like 6 fourths plus 3 fourths. And so when I add those together, I get 9 fourths. Just be careful that when you add fractions together, if you were to add them and get 10 fourths, then you need to simplify that down by dividing by what goes into both of these. So 2, since they're both even numbers, and you end up scaling it down to be 5 over 2. That's just an example. That's not how either of these have worked out so far, but keep an eyeball out for fractions that can reduce. Now this would work even if there were some more x's over here. You just have to make sure that you pile all of them together. So subtracting exponents is a vertical relationship. Adding exponents is a horizontal side-by-side relationship. I guess when would we multiply exponents? That would be maybe the next logical thing to think about. And if you remember, multiplying exponents usually happens when we have a group raised to a larger power. So if we have a group of things in here raised to the 2nd power, everybody would get that exponent. Now it would be wrong for me to distribute that exponent down below, because that y down here in the denominator is not included in our group. So only groups get the exponent that is attached around it. Now it's important to remember, when you distribute exponents, when you're multiplying, you do not have to have a common denominator. So maybe a separate example would be good to show this. If I had x squared times y to the 5th all to the 3rd power. You just distribute 2 times 3 and 5 times 3. Those exponents multiply by exponents. This works even if it's a fraction. So now distributing the 1/3, that would be x to the 2 times 1/3 and y to the 5 times 1/3. And it's okay to put these big numbers over 1. When you multiply fractions, you just multiply top, top, bottom, bottom. So you get 2/3 and 5/3. So not that hard. Actually, multiplying exponents is something you should never be afraid of because it's pretty easy. Adding and subtracting exponents, that's when usually you get those fractions and it can be a little bit harder. So what about some other things that we need to remember how to do? Well, negative exponents. If I have a negative exponent, let's say z to the negative 7th power, that means this does not really like being in that side of the fraction, and so it would want to jump to the bottom. Even if it's a negative fraction, like negative 7/2, you need to be careful. I always say they jump because you circle that group, you circle that base in exponent, and it jumps to the other side. Do not flip your exponent itself. It doesn't come down here and then it doesn't flip the little exponent. We've never done that. We've never flipped exponents themselves. So that's why I don't usually say flip, I say jump to the other side. Okay, and it's going to be important that you remember negative exponents have that action. When they jump, they just become positive in their exponent. Now, perfect numbers, also something that you really need to be on the lookout for because they can help you out a ton. Let's say you have 121. Well, 121 is a special number, 11 squared, and so occasionally if you're going to be multiplying in an exponent, distributing it in something, 11 squared can help cancel out that exponent. So be on the lookout for those perfect numbers. Or if you have a situation where maybe it is not 121 but 242, and on the top there is another constant or another coefficient that's 2. Well, these simplify down and you would end up getting 121 because you divide them both by 2, and then just kind of keep looking out for those perfect numbers. So be careful. Dividing and multiplying coefficients can help. Perfect numbers can really help. And then negative exponents, it's a good thing to remember that they just jump. So your quiz today covers all of these topics. It will not be a big mega problem like all of this together. There are separate problems that are kind of forcing you to recall these rules. But if everything I just went over here seems familiar to you and you understand it and you're comfortable with it, then you'll do great on the quiz today. First 2 questions are pretty easy. They're gimme questions, so you get a couple of freebie points, and then the rest of the questions kind of split up these different rules about when do we do this and when do we do that. So hopefully this little video helped. If you guys have questions, remember that we would always try to experiment on our calculator. If I have this thought about how these exponents work, does my calculator confirm that? And that's a good way to help you out. Otherwise, good luck today. I know you guys are going to rock it out, and I will be seeing you guys tomorrow. Okay, take care, everybody.